In reality, all he's doing is pushing the same buttons he always has. Nothing has changed.
Hello everyone, this is Tim, and I'm doing a tutorial on Wumbo today. Wumbo is a permanent manual challenge, so it's optional that you can attempt to figure out the manual. If you've never solved this before, you can attempt to figure out the manual based on the information here. I'm not going to be talking about that though. After you've solved the manual challenge, or if you've decided not to do that and just you want to see the manual, you have to click this button, and when you do, you won't be able to see that. You won't be able to see this page anymore, and you won't be eligible for the manual challenge ever again. Yeah, so we'll go ahead and click this for the purposes of this. Yep, there's a confirmation, and so this is the actual manual. We won't be able to, even if you refresh, so you won't be able to go back to the previous version of the manual where this was hidden. So anyway, now I'm talking about this now. So it's no longer in the phase where it's only a manual challenge. It actually has a real manual now, but it is still always an option to solve it as a manual challenge if you've never solved it before, if you've never seen the real manual before. Anyway, so this is Wumbo. It's the inverse of Mini, if you will. And so, like Mini, it looks different before you've selected it for the first time, and when you select it, something happens. So this panel opens just like on Mini, and you'll notice something a bit peculiar about Wumbo modules is they look like upside down, already solved Minis. So if you take a look at what a Mini looks like, it's the other way around, and the panels are not opened yet, and they're not so they turn green after you solve them. And so you can see with Wumbo, the panels are all green as if you've solved them already, and the status light is green as if you've solved the module already. But this is actually the unsolved state of Wumbo. So here, let me open this again. Firefox is being a little weird. Okay. Right, so what you have to do is take the tag number, which is very similar to how Mini works. The tag number is calculated based on multiplying together prime factors, where the exponent is the solution to each stage of the module in index form. So we'll open up a text field calculator here, and we will try and figure out the prime factorization of this number. 1, 2, 5, 9, 5, 4, 0, 1, 0, 0. Okay. So so the ones where it doesn't have a where it divides evenly are the ones where it's a factor. So let's see. It's divisible by 2 several times, only 2 times. You see, if I go to 3, it has a decimal point, so it's not. It doesn't have 3 factors of 2, or 2 to the 3. It's only divisible by 2 to the 2. So u would be 2, and so it is divisible by 3 also, several times. Oh, it's only divisible twice though. Okay. Yep, that one's the limit there. Wow, they're all going to be 2. So let's see. Is this the decimal point one? Oh, yes, it is. So it's actually, no, it's not. If this one is, it's this one. So it's divisible by 7 once. Oh, and twice, but not 3 times. Okay. 11, it's not divisible at all. So you can treat that like a 0. But that's kind of, yeah, well, we might as well. Yeah, because if you change it to 1, so it's a 0. 2, 3, 4, 5. It's got a lot of 13s in it. Yeah, so it can never go past 4, but for sanity reasons, I like to check 5 also. But anyway, the exponent will never go past 4 if you're doing it right. So actually, we don't even really need to write this down in Notepad++. But so we'll write down the numbers in reverse order. 4, 0, 2, 2, 2, 2. Okay, and the first panel was wires. I'll just put a W there just to remind myself. And we'll look over here and we'll see that 4 with wires means cut the white wire. So from this point on, it's very simple. So there's it actually does correspond to the mini flowchart. If you take a look, so we're basically unsolving a mini module. So it's upside down. It's already solved. You know, it looks like it's already solved, and we're actually unsolving it back to the original state, like that mini looks like. So so you'll see that it actually works out that way too, because let's see, white. So instead of using the flowchart for mini, we're just going to use this table lookup. But however, you'll see that it actually does follow the flowchart, but in reverse order. So there's no way for you to actually predict what the next panel will be until it opens, because the flowchart is based on which panels opened next. So you actually can't like reverse figure out which one's going to open next on Wumbo, because you won't know until the end that it actually it did actually make a logical progression through the mini flowchart. I'll show you what I mean. So we'll click the white wire, and then next up is buttons. So, and we don't really need this right now. Next up is buttons with a 0. So we're going to press the A button, the abort. And arrows is a 2. So we're going to press the button located top, and all of this is as if the module was right side up, so as if it looked like a mini. So the top located arrow is actually this one, if the module is flipped right side up again. So switches is a 2. Right here, we're going to flip the blue one. And keypad is a 2 also, center. Okay. So if it had been any of these other ones, you'd basically reverse this. So bottom left would be top right, top left would be bottom right, you know, as if the module was flipped right side up. And dial is a 2. And that's the 3 o'clock position. Again, flipping the module upside down, so that's exactly where it is right now, is the 3 o'clock. So I like to call that position 3 rather than 3 o'clock, and so this is position 1, 2, 3, 4, 5. But yeah, clock faces work too. It's just more confusing because the module's upside down. And there you go. This is actually the solved state of a Wumbo. It's the LED light, the status light goes off when it's solved, which might be a little inconvenient when you're trying to like look at the side of a bomb to see how many modules are solved. But yeah, this is actually the solved state. There's my lovely custom alarm clock. Isn't Sound Pack Maker grand? Okay, so let's bring this back. We're going to type in 2. I'm going to show you another one now. 210420210. So it is divisible by 2 exactly once. It's divisible by 3 exactly once. It's divisible by 5 once. Nope, not that one. It's divisible by 7 3 times. It's divisible by 11 twice. And 13 twice. Okay. So 2 2 3 1 1 1. Okay. This time we'll write down a little bit more information here. First one is switches. And so what we're going to do I just want to show you something cool about how it follows the mini flowchart in reverse. You totally don't need to know this to solve the module. So let's see. 1 switches 1 is white, so we're supposed to press the white switch, which in the mini flowchart, it matters what the position of the switch is, not the color. So the position of the white switch, if this was a mini, would have been top left. So if we had arrived at switches from wires, the answer would have been top left. So I'm expecting the next panel to open to be wires, if indeed the white switch is correct.
What? Really?
It's not, because that's not a 1, that's a 2. So the blue switch should be the correct one, and that would be the bottom left switch. So we're expecting the next panel to open to be dial if the blue one is correct. Yep, so dial's the next one that opened. So yeah, if we were solving a mini at this point, we would solve dial, and then the next panel that opened would have been switches, and the answer would have been bottom left. So yeah, you'll see that it actually works out that way throughout the whole thing. Okay, dial. Actually, I don't need to write anything else down because I've already explained that. So dial 2. Three o'clock. Okay.
What? Really?
Sorry, I didn't mean to press the center button. I meant to press. You got to be real careful about that. This one moves the dial, and this one submits the dial. So we'll submit on 3 o'clock there. I forgot to look at what shape it was. It was a square, and that would have been coming from keypad to dial. Keypad 3 would be top right. Okay, which would be the bottom left on an upside down version. So Charlie. Charlie is here in this range, so we're expecting the next one to open to be wires, if in fact this is correct, which it is, and wires opens next. So it's just kind of interesting that it follows the mini flowchart in reverse. Okay. Wires, number 1. Just write that in there so I don't lose track of where I am. Is a red wire, which would be the position 1 wire. So we're going to expect buttons to show up next. Yep, yeah, position 1 because the module's upside down. So buttons, number 1 would be the press button, which is yellow. And the yellow one would take us to arrows. So we're expecting arrows to show up next, and there it is. Okay, and arrows, number 1 is the bottom located arrow, which would be this one if you flip it upside down. And yeah, there's nothing else. Yeah, there we go, module unsolved. In fact, it says so in the log, module unsolved. And there we go, we arrived at arrows, and there's nowhere else to go because we've been to the other panels. So yeah, don't need to know about that. It's just a nice little quirk about Wumbo is that it follows the mini flowchart in reverse. But that's it. That's how you solve mini. You just gotta figure out some way of doing this prime factorization. I kind of like doing it like this. Of course, you could use a solver or something that factors it for you, but that's kind of cheating. So yeah, so that's Wumbo.